Welcome to Spring LIB.
All right. So we have X chlorine on one side and chlorine on another. I use the script L to distinguish it from I's whenever I write chlorine. So this is Cl. I just prefer a script L. And the question is this X, which is neutral, we should note, has no lone pairs, more likely oxygen, fluorine, beryllium, nitrogen, carbon, or boron? And what I would say is that we're looking for something that is in group 2, right? And that's because it's neutral, having only 2 bonds and no lone pairs, right? So group 2, beryllium, is our most likely answer. We'll see how this kind of makes even more sense when we look at the next one, in which we have Y in between 3 chlorines. Right, again, 3 bonds, no lone pairs. I would argue that this must be in group 3, which tells us that it is likely boron. Okay, and then finally we have a what is that? A Z? Yeah. With 2 sets of lone pairs, 2 bonds to chlorine. Right. And I would argue that this is going to be in group 6, because it is neutral, and therefore oxygen. How do I know this? Well, the rule for determining a charge on some sort of central atom with multiple bonds to it is that you take the group number. Let's put group number. You subtract 2 times the number of lone pairs and 1 times the number of bonds, and that tells you the charge. So I'll write C for charge. Well, in each of these cases, the charge is 0 because they didn't show us a plus or a minus or anything like that. So this is like saying group number minus, okay, for the first one, there's 0 lone pairs, so 2 times 0. And there's 2 bonds, right? So minus 1 times the number of bonds, which is 2, equals 0. Or if we do a little bit of algebra, basically you get that the group number has to equal 2. Right? If we solve for group number equals 2. And that's how I knew that X had to be in group 2. And do the same thing with number 3. You say it's the same math, except for this time there are 0 lone pairs and 3 bonds. So something minus 0 minus 3 equals 0. 3 minus 0 minus 3 equals 0. Right, so group number 3, that's how I knew it was boron. And for the final one, we knew that the group number minus 2 lone pairs, so that's 4, minus 2 bonds, so that's 2, equals 0. Okay, and the only number that fits here is 6, because 6 minus 4 minus 2 is 0. So I knew that Z had to be in group 6. Right, here's where, like, group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8 on the periodic table, right? Sometimes these are called 3A, 4A, 5A, 6A, etc., or 13, 14, 15, 16, 17, 18. But they're also just known as groups 3 through 8. And oxygen, coincidentally, is in group 16 or 6A or 6, depending on which periodic table you look at. Or either way, if it's called 16, we just refer to the 6. If it's called 6A, we just refer to it as 6. And if it's called 6, that makes things easy. It's already a 6. But 6 is the only number that fits in this equation and gives us a neutral output, because we knew that the central atom was neutral because it didn't show it with a charge.